Besides knowing how to build matrices in MATLAB, it is equally important to know how to operate on these matrices. Today, we will go over some simple operations for matrices. The first will be the transpose function. The transpose function allows user to turn rows into columns and columns into rows. For example, build yourself the matrix A. Now type in transpose of A. Notice our first row, 2, 6, and 8, has become our first column, and the first column, 2, 3, and 7, has become our first row. The shorthand for the transpose function is the single quotation mark. So, if we want to create a matrix B that's equal to the transpose of A, we can simply put B is equal to a quotation mark. Next, let's go over addition and subtraction in MATLAB. Addition and subtraction are elemental operations, which means we can only add or subtract matrices that have the same dimensions. This is because only corresponding elements are added or subtracted. For example, if we add A and B, the first position will be 4 because 2 and 2 are added together, and the second position will be 9 because 3 and 6 are added together. Similarly, if I perform A minus B, the first position will be 0 because 2 and 2 are subtracted from each other, and so forth. MATLAB also allows the user to perform elemental multiplication and elemental division. To do so, place a period sign in front of the multiplication or division operator, and the corresponding elements will be multiplied or divided. Similarly, you can also perform elemental exponentiation using a period in front of the caret sign. In order to perform true matrix multiplication, we use the multiplication sign without a period in front of it. Here is how the matrix multiplication works in MATLAB. If you're unfamiliar with it, please review a math textbook. But the general gist is the first row will be dot producted to the first column, and then the second row to the first column, and then so forth. So, to matrix multiply A and B, we simply put A times B. Note there is no matrix division in true matrix operations. In addition, order is extremely important when multiplying matrices. So, if I multiply B times A, I will get a completely different matrix than A times B. Matrix multiplication is extremely useful for solving simultaneous equations. Let's take a look at an example problem. Here's an example of a very simple simultaneous equation. X plus y is equal to 4, and 2x minus 3y is equal to 3. In order to solve this problem, we will represent the simultaneous equation using matrices, such that all the coefficients are in matrix A, the unknowns are in matrix X, and the solution is in matrix B, and we'll represent the form using A times X is equal to B. And because the inverse of A times A is equal to the identity matrix, that means X should be equal to the inverse of A times B. So let's create the relevant matrices. First, we'll create matrix A, what we'll call the coefficient matrix. And then we'll create the solution matrix, or matrix B. Okay. And again, in order to solve for the unknowns x and y, we simply have to multiply inverse of a times b. In order to find the inverse of a, we can simply use the inverse function in MATLAB. So if you type inv of a, you'll obtain the inverse. So if we multiply inv of a and b using matrix multiplication, we will find that x is equal to 3 and y is equal to 1. If you're unfamiliar with these types of simultaneous equation problems, please review a math textbook and do some more practice problems.